Back in 2001, I was actually an engineering professional at a very large telecom company whose name you would recognize. I was actually in the process of trying to clean up some files on my system, and I accidentally ended up deleting the file containing all of my emails for the previous 3 months. Well, naturally, I was less than excited about that. The good news, however, is that I had been archiving my system periodically, so I only lost 3 months' worth of email. And that really underscores the importance of archiving, backup, and mass storage, which is the purpose of what we call external storage in computing. A very vital function, especially with failure rates of different components, and it's a way to be able to protect yourself against data loss. Let's take a look.
Let's begin with external disk drives. Now, a saying that I frequently use is simply all resources are finite, meaning everything has limitations, and this includes our ever-increasing dependence on technology. Unfortunately, this means that bad things can and unfortunately do happen, including dropping a laptop, a disk drive permanently crashing, data being deleted or erased, a virus destroying all information contained on a system, and so forth. And this is essentially the purpose of backup or archiving, and can make the difference between a minor or incremental data loss and a catastrophic incident, such as envisioned here with this particular hard drive. Trust me, there is nothing being recovered from this particular device. Now, while external drives are useful in this regard, other legitimate reasons exist, such as collaboration or data sharing. But many times, one of the primary reasons for using external drives is for archiving and backup. Now, there are different connection interface types. You actually see pictured here an external disk drive array. And there's a variety of different connection types that actually can be used. First, there's eSATA. We talked about eSATA earlier. This is simply an external connection to a SATA type of drive, serial ATA, as opposed to the traditional parallel ATA or PATA. So this is eSATA. It's one connection type that can be used. You also have USB, which is fairly common. A lot of the passport type of drives where you can actually use for archiving different types of information will frequently use USB. The version of USB obviously determines the kind of speed of transfer, but it's another very common connection methodology. Then you have IEEE 1394A, or sometimes referred to as FireWire. It's a different connector than you actually see with the USB here, but there is some similarity in the way that the plug looks. And aside from dealing with just hard drives used for archiving, it can include optical drives as well, and even floppy drives. For instance, external floppy drives are usually attached by USB or some other means. If you've been involved in the personal computing world for any length of time in recent history, you're going to be infinitely familiar with the most popular form of external storage, namely flash drives. Flash drives come in all shapes, sizes, and form factors, and we're just going to take a look at some of the more popular ones, but definitely these are something that you're going to run into quite frequently because of their ease of use. Now, one of the first types of flash drive is actually a small card, which actually can be inserted in some case into the chassis of a laptop, or you can use any one of different types of adapters, which is actually pictured here. And there are a number of different types of cards that are actually pictured here. First, you have what's called compact flash. This was used in some early digital cameras and is actually used a lot in Cisco computing environments and device environments where you typically have an operating system or file for execution stored externally. And that's kind of the purpose of this. You can see it's somewhat larger compared to the others, and so there are different sizes and such. Then you have your MMC SD type card. You actually have your mini SD and your larger types, and this again is used in a variety of different things such as smartphones, cameras, and so forth. And again, there's a variety of different types, and some are compatible and some are not. In fact, when I first got one of my smartphones, I actually had a very large capacity card that I wanted to put in, but unfortunately wasn't compatible with the phone I was using. So you always have to be careful about compatibility. Then you also have the mini SD and micro SD, which generally are physically smaller. In fact, if you want to use those with the full-size SD, usually there's some type of an adapter. But again, these are just some of the many different types of flash cards you may run into. And again, what's pictured here is actually an adapter to allow it for interfacing to the system. Certainly the best known type of flash drive is actually a USB-based flash drives. They typically look like a stick, and they can contain anywhere from 64 megs up to, it's just becoming staggering, the amount of information that's available on these. But in this particular case, You could see a variety of different sizes here from 1 gig up to 6.4, and actually there are 32 and just a lot of different sizes that are available, and these will continue to advance. And they're really great because you can actually plug them in, your system will recognize them, load the appropriate drivers, and then you can just read and write to them just like it's a drive that's internal to your system. And then when you remove it, you can obviously share it with others, as well as back up different things. My computer was recently having issues, and I used an 8 gig flash drive in order to be able to keep some specific files related to this course and some other things to keep from being lost or corrupted. Turned out it wasn't a serious issue, but it's a great way to be able to take care of that in the short term. So with removable storage, you need to understand the capacity of the media, the physical size, the speed of the device, and one of the most important things, especially with flash drive, is the whole issue of security. Because these devices are so convenient and so easy to use, very sensitive data can be on them, and they can be misplaced, stolen, lost, and end up giving very important data to people that really shouldn't have it. So always keep that in mind. There are some ways to be able to encrypt flash drives, and there's also different operating system types of features that can actually lessen the potential negative impact from a storage perspective. So flash drives, great tool, but to be used with caution. Now, under the general category of external storage, it's really important to talk about backup and archiving. Because of the consequential data failure rates, mean time between failures, and so forth, you need to take this seriously. And that brings us to the concept of backup storage. There are several different types of technologies that are available, especially now that the development of backup technologies has gotten so great. And there's a variety of different types that we want to talk about in this section of the lesson. First, we want to talk about tape drives. What you see here is back from the days of the mainframe, and tape storage at that time was popular, and even when the PC era was inaugurated, it continued to be used. For instance, the Radio Shack TRS-80 platform used a cassette recorder to be able to read and write, obviously very small amounts of information, typically data storage, and you would load programs from that as well. Tape drives, however, have continued to be used with servers to facilitate large-scale backups of systems, and servers in particular, in fact. And typically you will see large tape libraries, and there is a very strict regimen of backup procedures creating a large number of tapes, such as you see here, for preserving critical data. Now, tape drives can be internal, as you would see pictured here. You obviously see this is designed to be put into a system. Then there's obviously external. This is some of the types of cartridges that are used. A variety of different types of connectors are used to be able to actually access these types of systems. They could be SCSI, which we'll cover later, PATA, SATA, USB, and FireWire. And even in addition to that, there are obviously a large number of vendors that are available in terms of tape backup. One of the most popular types of technologies for preserving data is called RAID. Now, RAID is not a spray for killing insects, though that may be the first thing that comes to your mind, but it actually stands for Redundant Array of Independent Disks, or Redundant Array of Inexpensive Disks. I have to be honest with you, this is one of those terms that sometimes is confusing because you don't always hear the same term used. It's like that with a lot of things. But the official CompTIA designation was Redundant Array of Inexpensive Disks. And basically the whole point is, it's great if you have a disk within your system. In this case, this is just a representation of a hard disk in the system, and everything gets stored there. But what happens if there's a catastrophic incident in which that particular disk is compromised? And that's actually the whole purpose and understanding of RAID. So instead of one disk, you're going to have multiple disks on which to store information. Now, if you just have disks alone installed in your system, which you could do through a variety of different connectors that we've talked about, it's sometimes called JBOD, J-B-O-D, which stands for just a bunch of disks. Doesn't sound very technical, but it's used quite often. And basically it means you're treating each disk as a separate entity. So you might actually save it to a C drive or a D drive or an E and F drive, such as you see pictured here. But another thing you can do is with RAID, you can actually put these into a single collection. And in this case, physically, they still are 4 separate disks. But logically, this is what that same array of 4 disks is, a single logical drive. And this is how RAID actually works in a couple of different ways. And there's more than one RAID type, and we're actually going to discuss that. But the basic principle is being able to use multiple disks as a single logical array. Now, the types of interfaces that can be used, SCSI, which we'll cover later, which stands for Small Computer Systems Interface. And we talked about ATA. In this case, it would be PATA, Parallel ATA, and SATA, different types of interfaces that can be used for connectivity. Now, there are different levels or types of RAID, and it's actually designated with the use of different numbers. So we want to talk about the different types and how you could possibly use them. Now, this is not exhaustive. We actually have a companion handout available for these lessons, which will detail all the basic types that you'll run into. We're just going to go over some of the major ones right here. First, we have what's called RAID 0, or striping. Now, we start with the same 4 disks as we talked about them before. You need a minimum of 2 disks for this to work. And again, you're still looking at a single logical drive. Here you actually see a graphic of a file, and you're going to see how this file is put across both the drives using what's called striping. It's a way of writing data to these individual drives, again, looking at it as a single logical drive. So one piece goes to one file. And this is the basic concept of striping. You actually have several segments of the file being written to one disk and several other segments of the same file being written to another disk. Again, single logical drive, but the idea is to be able to spread this out a little bit among these different types of arrays. Now, the good news with RAID 0 is that you get very high performance. You're able to write at a much higher performance than you would just having 2 individual disks. But the bad news is that there's no redundancy. For example, if the disk on the right with segments 2, 4, and 6 of the file were lost, the whole file would be lost because there's no redundancy built into this. It's basically a higher performance type of an environment. Because of that, RAID 0 was actually surpassed and has been surpassed by other mechanisms which actually seek to build some redundancy into the system. So we have the same situation with the disks, but with RAID 1, we actually have what's called mirroring. And again, you need a minimum of 2 disks to do RAID mirroring. And again, it's a single logical drive. So we have our file again. In this case, what we do is we actually write the same segments of the file to both drives. So in this case, if the drive on the right is destroyed or compromised in some way, you can actually see you have the full contents of the file already preserved in the other drive. So it's a lot like having a spare, if you will. Now, obviously, the strengths of the RAID 1 system is you still have that high performance, but now you have redundancy. So again, if there's a failure, and you do this in groups of 2, so either you're going to do 2 disks, 4 disks, and so forth, whatever your system's able to physically handle, but it's actually a mirror copy is written to the other drive. So you have your redundancy and your performance both built in with RAID 1. Next, you have RAID 10.
Now, while we refer to this as RAID 10, and it's pretty much called that universally, it's actually RAID 1 plus 0. We talked about RAID 0, and we talked about RAID 1, and it's actually a combination of the two. So keep that in mind when you hear RAID 10. It's technically RAID 1 plus 0, but you'll hear it referred to consistently as RAID 10.
Doesn't it make sense that you'd want the high performance of RAID 0 with the redundancy of RAID 1? That's just essentially what you're talking about with RAID 10. You have both striping and mirroring. So we start with our 4 drives again. In this case, we're going to use all 4 drives for this. So we're writing our file just like we did with RAID 0 that we talked about. But then there's a write operation that's actually going to duplicate that on the other drives. So you have your high performance, and if you have a failure, you're still able to reconstruct the entire file. Very sharp, very efficient. Then you have RAID 5. RAID 5 operates differently, and we'll actually show how this works right now. So instead of having 2 as a minimum, as we did with most of the other RAID levels we talked about, here you have 3. Same file that we've been looking at before. So as it's being written, notice you see P. P is what's called a parity. And you can see parity is actually written to these disk drives along with the contents of the file. Now this is significant because those parity segments can be used to reconstruct any one of these failed drives. It's a very complex mechanism, but essentially these are used to be able to reconstruct something if one of these three drives fails. So in this case you have three, you're able to reconstruct it doing the parity, and this really gives you a great deal of benefit in terms of redundancy. And again, this is not completely exhaustive of the different types of RAID, but it gives you a good feel for how it operates. Now, above and beyond just simply using RAID, there's also something called a NAS, or Network Attached Storage. And this is important because these have become very, very popular in a lot of environments with a lot of different types of vendors such as EMC and Network Appliance and so forth. And keep in mind that Network Attached Storage is a file-based storage system. Essentially, you have two types of file systems. You have file-based, which is what you typically use just from day to day anyway, like with your Windows operating system and so forth. And then there's actually what's called block-based storage system, so actually every block that's on the disk is actually being written. And that's kind of beyond the scope of what we're going to talk about in any depth, but just suffice it to say that network attached storage is a file-based storage system. In addition, it is network or IP-based. So there are types of read and write operations that are actually done over an IP network infrastructure. These are going to be Ethernet attached, means they're just like another device on the network. It's like a giant file server in a sense, but this is the whole purpose of network attached storage. And often it is appliance based, which you actually see pictured here, where there are multiple disks. Again, they're using RAID, but they're actually a standalone array that's actually accessible via the network in terms of storage, reading, and writing. A lot of devices that you can buy now actually allow you to be able to do this. Contrasted to network attached storage, which is network based, is storage area networks. Now, while strictly speaking these may not be topics on the A+ exam, as a PC professional you need to be able to know, understand, and interact with systems like these because frequently you'll be called upon to do so. As I mentioned a moment ago, the network attached storage is a file-based storage system. With storage area networks, it is a block-level storage system. We sort of looked at a rudimentary version of that with striping and RAID, but the whole idea is you're taking a block of data from a disk and you're storing it to an array using block-level storage rather than a file. It's often directly attached. There's a series of connection options called fiber channel. It can be spelled F-I-B-E-R, F-I-B-R-E. It's frequently going to be used with fiber optic cabling, in fact, but that's not why it's called fiber channel. The point is that you actually use this in some kind of a direct attachment rather than a network attachment. So that's the thing to keep in mind. Storage area networks are directly attached to some sort of fiber channel mechanism. Now, there is something newer called fiber channel over Ethernet, but it's still dealing with a block level type of storage. And again, you're going to be using some kind of dedicated network and a set of very specialized fiber channel switches or fiber channel over Ethernet, as we had discussed. And storage area networks are in and of themselves exceptionally complex. Network attached storage tends to be very simple by comparison, but storage area networks can be very complex, and consequently they can be extremely expensive as well. So just something to be aware of. So as part of our lesson about external storage system, we actually wanted to demonstrate, just using this particular laptop, how this actually works. I actually have an SD card. It's a 512 megabyte card, very small. It was part of one of my very first Windows phones. And I'm actually going to access it on my system. So I have it in the little adapter that I have, and I plug it in. Notice it came up right away. It had already installed the drivers. In this case, I could actually look at a variety of different things, and we have a whole different type of element here. And then if I want to stop using it, I can use the eject function, and then it goes away. If I was to do this with a different flash drive, in this case, it's actually installing the drivers. Notice here it recognized it. It installed the drivers, and then it said it would be ready for use. And again, I can look at this right here, and this is for another course that I taught at one time. So it's a very easy process with these external flash type drives. And this is a very simplistic demo, but it really gives you the kind of idea of how external drives are used and what the process is that you're going to go through when you choose to install them on your system. Thank you for listening. So as we wrap up external storage, let's just talk about a few important terms. First, there's RAID, and remember there are two designations for this: redundant array of inexpensive disks or redundant array of independent disks. And this is a storage mechanism using multiple disks designed to increase performance and protect against data loss. eSATA, External Serial Advanced Attachment Interface. This is a connection using SATA interfaces and designed for supporting externally attached hard drive. This is as opposed to regular SATA, which is actually a port to be plugged into on the motherboard. You have NAS, or Network Attached Storage. This is a file-level storage system that is accessible across a TCP/IP and consequently Ethernet network. Network Attached Storage. Then there is SAN, Storage Area Network. And this is a block-level storage system that frequently uses a dedicated network to provide backup and storage services.
Now, as you can see, there are multiple options available for users to be able to archive data. External hard drives, flash drives, all sorts of other things that are good options for being able to do that. However, just as with the Force in Star Wars, there's both a light side and a dark side to this. The light side is you can save your data, you can minimize data loss, but at the same time, those devices can mysteriously migrate maybe into the hands of people who shouldn't have them. The point is, you need to make sure that there's a good policy for mitigating that and to be able to maximize the benefits without creating greater drawbacks. Now, we have lots more to cover in our A+ course, so stay tuned.